Hello guys. Today we create a chain rule. Chain rule is one of the rules of differentiation. So chain rule yona e apply on composite functions. So let us do a reminder ya hore nahana composite function ke. A composite function is when you have a new function e o e etsang ka di-function tse ding. Mohlala, suppose that you have f of x equal to x squared, and maybe you have g of x equal to the square root of x. So a new composite function, let me just call it y, would be maybe f of g of x. What does this mean? It means that g of x is the input into the function here f. Okay, so while a composite function means that you have an outer function and an inner function. Inner function is your input here, right? So in this case, our function f squares the input. So if we have f of g of x, this says we are going to square whatever we input, right? So this says to us that we are going to square the square root of x, and this simplifies to x. So f of g of x is equal to x. And it gets more complicated. This one is an easy one. It's a function and its inverse it's a cancel out. Let's get more complicated. Functions. So you have your f of x is equal to 1 over x, and then maybe you have g of x is equal to sine of x. Yeah. Now, in this case, say you want a new function, g of f of x, right? So this means that this is your outer function and this is your inner function. Now this is going to be an input in another function, right? Function ya g is sine something, sine of the input, and our input in this case is 1 over x. So looking at y is equal to sine of 1 over x, this is a composite function with an inner function and an outer function. Usually when you have a composite function, to differentiate you have to use what we call the chain rule. So we are going to apply the chain rule to see how it works. So this is also an introduction to the chain rule. Stay with me. Going back to our workbook, we realize that we have this here. This is a summary, but let's consider this example. We'll go back to the summary. Generally, our equation y is equal to e to the power x squared plus 2x. First of all, you have to identify the inner function. So we realize our inner function is x squared plus 2x. And then we let u be the inner function. So mona step sa pele we realize we equate the inner function to u. And then afterwards, this means that your y is equal to e to the power u. Remember that we just said x squared plus 2x again u, meaning here e to the power u. And then the next step is compute du dx and dy du. So mona re tlo tla re etsa derivative of u with respect to x du dx, and using the rules that we have studied earlier on, re ba le 2x plus 2 as a derivative of this one. And then ebe hape re tlo tla re etsa derivative of y with respect to u. Then we have dy du is equal to e to the power u. Ebe he ka mora mo, the next thing from here, you have to multiply the derivative in 3 the derivatives in 3 above to get dy dx. So essentially dy dx is going to be a product of du dx by dy du. If this and this cancel out, then you're left with 1 times dy, which is dy, and then dx times 1, which is dx. It makes sense that dy dx is equal to du dx times dy du. Now this is our du dx and this is our dy du. This is where you are going to multiply the two, and this is what you get. But however, u has to be replaced by this. So because re batla derivative of y with respect to x, in our expression mona re lebeletse gore re be re na le di y le di x fela, re se re sena di u. So dy dx would be, remember you replace u by x squared plus 2x. So it will be 2x e to the power u yani is in terms of x. And then 2 times e to the power u, remember to replace u by x squared plus 2x. This is our first example, chain rule. Let me see if we have another example here. If not, we'll create another. All right, let's do this one. So remember the steps that we had. We first identify the inner function and we let the inner function be u. So in this case our inner function is x cubed, and then this implies that our y is now equal to sine of u. Now the next step, remember, is to find du dx, in this case 3x squared, and then we have to find dy du, which is, what is the derivative of sine? Cosine u. And then we are going to multiply the two now to find dy dx. It will be 3x squared multiplied by cosine of u. And remember now, okay, it's a derivative of y with respect to x, meaning that u has to be in terms of x. Therefore we have 3x squared cos x cubed, right? So this is our answer. That one is easy. Let's do another example. From our workbook, we have y is equal to x squared plus 5x all to the power half. Okay, so let's do the derivative here. The first thing for you to do when you realize you have a composite function is to identify an inner function and the outer function. So in this case, our inner function is x squared plus 5x. This implies that our y is equal to u to the power half. Now, what's the next thing to do? To find du dx and dy du. Usually, our du dx will be 2x plus 5. Remember the rules that we studied earlier on? And then in this case, dy du would be half u to the power minus half, right? And you can write this as half times 1 over u to the power half to avoid confusion, and this gives you 1 over 2 square root u, right? And then to find the final answer, dy dx, what do you have to do? You have to multiply dy by dx ka dy du, and this gives us 2x plus 5 times 1 over 2 square root u. Now I'm going to write u in terms of x, x squared plus 5x. Right. And now this works out to be 2x plus 5 over 2 square root x squared plus 5x. So I'm going to give you more activities for you to practice the chain rule. Right. If you have any questions, you can find me on my WhatsApp.